Greetings, let's say we have a complex valued matrix, and how do we deal with it? Actually, it turns out it's quite same like with real numbers. So we see complex numbers here, and this is a system of two linear equations put into an augmented matrix. So it's xi plus 2y equals 1, and the same way for the second equation. And if we want to solve it, normal matrix elimination will work. So what we can often do that helps, if we have a term like this, that's a linear term of an I, and then there's a number below it. If we want to cancel out one with the other, in other words, I mean somehow add a multiple of one row to the other, I would first perhaps multiply by I. So we can multiply by I the first row. That will help change the first column into real numbers only. So we would have this, and the second row I'll keep still. So we will have this. All right, so now we have this, so we can add the first row 3 times to the second. So what we can get is basically 0, 8i, and 2 plus 3i on the right side, still an augmented matrix. The first row is not changed this time at all. And now we basically got to quite a reduced form. We see this is a pivot, and that's it for the rows, 2 rows. So what we can do now, solve it as a system of linear equations, convert it back to x and y. And that would be minus 1 times x, like this. That's the first row. So it's possible to solve for x, for example. We would have 2i times y minus I for x. And for y, well, 0x plus 8i y equals 2 plus 3i. Well, that would be that y is 2 plus 3i over 8i. Alright, so in terms of this complex number, we can do it. And that means now we have y in terms of just complex numbers and not the other variable, but we have x in terms of y. So I would put it back there. We would have x being 2i times what is y, this. Alright, minus I itself. And that would be, this would reduce to 4 down here. So x would be 2 plus 3i over 4 minus I. Alright, so the solution for the system would be this column vector xy, where x is this column, y is this column, equal to following things, 2 plus 3i over 4 minus I. And of course, this can be further put to the same denominator and change slightly, but we don't have to do it. I mean, you can do it, just make the denominator for both the terms the same, so 4i over 4 and stuff. And then for y we have already this, so here we go. Of course, this could also be changed slightly. You could, for example, multiply denominator and numerator by I. Alright, so here's the solution. So as we see, you can have a complex number valued matrix with linear equations with complex coefficients, and these row operations, elementary row operations, will lead to such a result like this, and it works for higher order linear systems as well. Alright, so we saw an example of it.